At time t is greater than or equal to 0, the acceleration of a particle moving on the x-axis is given by t plus sine t. At time t is equal to 0, the velocity of the particle is -2. For what value of t will the velocity of the particle be 0? So notice that what we're being asked is to basically, given that the velocity at time 0, -2, we have to find the value of t such that the velocity function is equal to 0. Okay, and that's precisely the last sentence here with the question. Okay, so as you understand, since we're given acceleration function, we should first find the velocity function because that's what we're going to be working with. Okay. So now realize that the velocity function in general is determined by adding the initial velocity, which here will be given as -2, plus from 0 to t the integral of t plus sine t dt. Okay, and that overall, together with the initial velocity, will give you the overall velocity function. Okay, so now what we want to do, we want to set the initial as -2. All right, so we want to basically make that substitution here. So the velocity function and will be what? It will be -2. And first of all, we want to also substitute the velocity function with 0, right? Because that's what the last question requires. For what value of t would the velocity of the particle be 0? So let's basically substitute this value with 0. And then the initial we're going to substitute with -2. And then let's determine the definite integral of this. Notice it's going to be fairly easy because you're basically substituting your overall result with t and 0 whenever it's applicable, right? So this one will be 1/2 t squared. And the good news is you don't have to, do this because it's going to give you the same result, right? Because you're going to substitute t squared with t, and you're going to subtract the 0, but the 0 doesn't matter because it's no quantity, right? So you might as well just ignore this. It's going to be this. And then the antiderivative of the sine is the negative cosine, right? So minus cosine of t. Now here you cannot ignore from 0 to t because the cosine of 0 is not 0. Right? So let's simplify this. So -2 plus 1/2 t squared minus, and then we're going to plug the top first and then subtract the bottom inputs of the function, right? So cosine of t minus, so the top minus the cosine of the bottom. All right, and what that would give us is what? That's going to give us 0 is equal to -2 plus 1/2 t squared, and then minus cosine of t, and then this one, cosine of 0, as we know, is 1. All right, and there are two minuses, so it's just plus 1. Okay? So now what you want to do, you want to basically have a 0 on one side and non-zero on the right side. And that's exactly what we have, but we have to also add the like terms here. So what I want to do, I'm going to switch sides of this equation. Basically, I want the right side to be written on the left side to make it easier to read. So what I'm going to have is this, 1/2 t squared minus cosine of t. And then 1 minus 2 is -1, and that's equal to 0. Now, of course, you can't solve this by hand because this looks like a quadratic, but we have a middle term that's cosine, so you can't really do this. But using a calculator, you can plug this into your calculator, scientific or graphing one, I believe, and then the result should give you the t value that will be positive, right? The result will give you 1.478. And of course, you want to round it to the nearest number here that makes sense. As you can see, 1.48 is going to be the closest result here that makes sense. right? So the correct answer choice is 1.48. So I hope this was useful and helpful. Thank you so much for watching, and I'll see you in the next video.